Hey, seventh grade. I hope you guys are looking forward to a great weekend. I have missed being at school with you guys this week, and I ran into a couple of you after school today when I was picking up Laura. And I just wanted to give you a quick sort of crash course in the notes that I left for you guys today. I'm proud of you all for sticking with it. Mrs. Gastineau said y'all were amazing, and I appreciate that. But I wanted to give you a little bit of a further explanation on the concepts that I left for you for notes today. So that's what I'm going to do. Okay, so here were the notes that I left for you guys. And essentially, as you saw, we talked a little bit about how problems that look like this, that have decimals, or look like this with fractions, are really just the same as simpler equations in terms of them being solved the same way. But because those decimals and fractions are in them, some of us have an aversion to them. And so this really is just a way to kind of get rid of those decimals and fractions. So let's start with decimals. When I look at this decimal problem that was on your notes, my goal is that all of these decimals basically go away. And we know that in math, the decimal doesn't just float off. But if we multiply by a power of 10, then it makes the decimal appear to move. So if we multiply by a positive power of 10, the decimal moves to the right, and a negative power of 10 moves the decimal to the left. So for instance, if you multiplied this 0.06 times 10, then your decimal goes 1, 2, and you end up with 6. And same thing over here, if you multiply the 0.045 times 1,000, then you go 1, 2, 3, and you end up with 45. So back up here at our sample problem, we need to look and think, what are the powers of 10 that we could use to move the decimal in this problem? And to keep it equal, of course, we have to multiply every term by the same power of 10. So if we multiplied by 10, then of course this decimal would move. But it also only moves this one place and this one place. So we need something bigger than 10. If we come over here, this would be 2 places, so that's 100. But this really is the furthest. We need to go 1, 2, 3 places. So the power of 10 that would move our decimal 3 places is, of course, 1,000. So on our notes, that's what we did. We multiplied all the first terms by 1,000 and the term on the right side of the equation by 1,000. And the result was negative 200 plus 30x equals 4. Yay. Okay. And I think what you'll find is if you work these out, when you go ahead and solve for x here and solve for x here, both times you will get the same value. So we're not changing the value of the equation at all. We're just simplifying the equation so that we're dealing with just whole numbers. Now, let's look at the fraction problem. We've got 5/3 x minus 1/2 equals 3/4. And what I'm looking at here is, what's a number that I can multiply by all of these fractions that when I multiply by it, it will cross cancel the denominator out, because that's really my goal. If I want to get rid of fractions, I have to somehow cancel out the denominator. Well, 12 is the number that we can use. It's not the only answer, but it is a answer because 3 goes into 12 evenly, 2 goes into 12 evenly, and of course 4 goes into 12 evenly. And so when I do that, again, we're going to take it term by term. 3 cross cancels. 3 divided by 3 is 1, and 12 divided by 3 is 4. We're left with 4 times 5, and that gives us 20. Over here, 2 divided by 2 is 1, so 12 divided by 2 is 6, and 6 times 1 is 6. Then on the other side, 4 divided by 4 is 1, oops, and 12 divided by 4 is 3, so 3 times 3 is 9. And now we've got this nice, clean problem to solve for x, okay? Could I use a different number besides 12? Sure. There are truly infinite number of options that will still get me to the same place. If I use 24, again, 3 simplifies to 1, and 3 goes into 24 8 times, so now you have 8 times 5. So just as 24 doubles the 12, each of these terms is going to be double, but because of proportions, you'll still get the same answer when you solve for x. So give it a try. Hopefully that helps a little. This is not ideal, but I didn't want you to be so frustrated that you threw in the towel and didn't give these problems a try this weekend. So you guys have a great weekend, and we'll touch base on this Monday.